Hello, everyone. Just give me 1 second. Is this microphone? Yeah, just give me 1 second. I need to finish one thing. I'll be right back. Just give me 1 minute. 1 minute. All right. Am I back? Am I back here? Where am I? Yes. Whew, that was a lot. Okay. Am I here? Am I present? Sorry, I just had a call that was urgent and that I need to address, and then I need to write something down, and I had to, life, real world life, sometimes takes in the way. This is actually that is not fair. This is real world life. The live stream, YouTube. This is like also real world. Like it's just we tend to call it. I don't know. I'm over conceptualizing this. Anyway, hello and welcome everyone to the 102nd live stream of Parametric Camp in our lifetime. My name is Jose Luis. This is Parametric Camp. We do computational design live streams. We record tutorials. We do practice exercises. We hang out, right? And then some of those videos we end up editing them, chopping them, and turning them into formal tutorials that we put on the website, and that people use and enjoy to learn more things about how to be creative using computer code. All right. That was the spiel. If you didn't know what we were doing already, but if you do, just like many people that I can see on the live stream, many familiar faces: Nicolas, Nightic, Joe, Pedro, Drillion. Good morning or good afternoon, everyone, or good evening, whatever this is finding you. So, if you want to know more about what we do, feel free to follow us on social media. We're particularly active on Instagram. Otherwise, if you want to know when we go live, we have a Google Calendar you can subscribe to in the description of this video. And we also have a Discord server that we use to continue the conversation throughout the week. And there's a lot of activity, but like people posting questions, other people helping each other. It's kind of nice, and it gives me also the opportunity to get to know you a little more. Okay. Now, what do we have today? What are we doing today? Well, a couple things. First, look at what I just got. Da-na-na-na-na. Can I see? Can I show? Oh, is it showing the right way? No, it's showing mirrored, right? Yeah. Well, I just got this. It was a gift, but I've had it for 1 week in the room, not being able to use it because I've been really busy. But thankfully, I'm a little less busy these days now, so I may have time to check it out. And who knows, maybe we get to actually make a live stream with virtual reality, and that would be kind of cool. I wonder I wonder how could we hook this up to the live stream so that you see what I am seeing or something like that. That would be really cool, I think. Indeed, yeah. So I'm going to give this a try and then I will follow up with you, see what we do with that. Have you seen my mug? You've seen this mug before, right? My friend Juan Adolfo gave it to me as a gift as well. And what else are we doing today? What else are we doing? Well, we're continuing. So, more announcements. I am wrapping up the semester at the university. If you don't know me, I teach computational design courses at the Harvard Graduate School of Design as of the recording of this video. So the semester is winding down, and I will finish the semester in 2 weeks, which will hopefully give me some additional time to Nicholas, that was awesome. That was very funny, actually. So I will hopefully get have some time, some additional time to go back, and I really want to finish the Grasshopper Advanced Development in Grasshopper series. So I'm actually thinking of like a 1 week intensive. We've done this before, of like 1 week where we may live stream every single day and then finish the playlist and just push it out and publish it out in the world and then move on to the next thing, which I'm not sure what it's going to be. I believe it might be a quick Git, let's learn Git and GitHub kind of playlist, just something quick. I need a change. I've been doing Grasshopper for way too long. So that's one thing. But I also have a few ideas of other cool topics that we could do and some explorations that I want to. So one thing that I've been meaning to do, this is, I don't want to disclose this or promise anything, but one thing that I've been meaning to do is, I don't know if you know this, but I'm a big Minecraft fan and I've been playing it for many years, and now I play it with my nephews, my nephews, my nieces, and by myself as well, and my brothers as well. So, and I don't know if you know, but Minecraft saves the 3D worlds in this proprietary format that is very well documented and that you can extract information from. So I wonder if writing something where we write code to read the chunk files where the 3D worlds are stored and displaying them in Unity or showcasing them in Unity or in Grasshopper, whatever, and like throwing shit. That would be really cool. But like writing it from scratch, I kind of want to do that. Is there a? There's got to be someone must have done a Grasshopper plugin to do Minecraft, right? Someone must have done that. Oh, there hasn't. There isn't. Interesting. Can you see this? So, Food for Rhino doesn't give me any Minecraft results. I wonder if that could be a cool thing to just write a Minecraft plugin for Grasshopper together, to just read the MCA file format. Okay, I'm gonna think about this. Okay. By the way, are you guys familiar with this project, Mineways? So this is, if you're a Minecraft fan, if you're Minecraft fans, this is a really cool project by Eric Haynes, who is a colleague, and he used to work at Autodesk, and I believe he's now working at NVIDIA. But he wrote this thing that parses Minecraft chunks, and then it allows you to render them, or allows you to 3D print them, multicolor. It's really cool. So maybe we can actually take this and write like a Grasshopper thingy. You can export a web through sketch file or render. So maybe we can actually, instead of writing it from scratch, we can use this. I don't know. We'll see. So I'm thinking about this. Anyway, today, what we're doing today is we're continuing the series. We're going to continue the series and this advanced development in Grasshopper series. And what we're going to do today is we're going to talk about persistent states. So the idea that a component may keep memory throughout different iterations of its execution. That's one thing. And the other thing is that we're going to extend that to do auto updates. So a component updating itself instead of having the ticker linked instead of having the timer linked automatically. So we're going to do that, and I want to record 2 videos talking about that, discussing that, and then hopefully we have time take one of the examples for simulations and porting it to native Visual Studio. So that's what we're doing today. How are you, folks? Metaverse, take it to the metaverse. Unreal Engine 4. Interesting. Maybe we can do some of that. But that's C++. That's like serious coding. Just letting you know. Richa, very happy you made it to the live stream. Welcome. All right. So let's get started. Where were we? It's been a while. Sorry, I've been really busy. It's been a while. Let me turn off my email because it's distracting me tremendously. So, okay, so let me actually go back before to my previous files. Let's open a little bit of Rhino here. Let's open Rhino. Let's open Grasshopper. By the way, who watched my previous video on Grasshopper 2? How are folks liking Grasshopper 2 so far? Feel free to drop comments on the chat window. So for PCamp, we did advanced development in Grasshopper. We've been doing this since August. I really want to move on. So maybe we're doing the intense thing like very soon. So continuous execution. I think it was continuous execution that we saw that idea. Persistent data, continuous execution, extended. Okay, so that was continuous execution. Oh, nope. So continuous execution. It was this video. Hi, this is Jose Luis here. Welcome. This is me. Camp, blah blah blah. Whatever become about the stage or so executions. Okay, so this is how I explain. One is Greeks is like going to be equal to that value. Because this data is persistent. Be helpful not to this for the week. So that's what was like this in Rhino. Yes, and I wrote this example. The unit in the x direction. You see that? Right? Now the problem is that example maybe P, the rule of un does reset point. Now move from those 2 points. I could do this with C. And the file was this one. The 2 files were, this file was iterations, executions, and what is A? Okay. Grasshopper is too cool. I think David's playing with us. Unfortunately, I felt a bit weird to watch a live stream, but not live. Well, I mean, time zones are complicated. You know, it's fine. Iterations double the value. Okay. Okay, so that's one thing, and then the other one was just taking a location and a vector and just updating. Okay. So I guess what we need to do then is that we need to start our parametric comp plugin. Which, by the way, how is the plugin going? Utilities, data, vector, construct. So I guess in the native components, preview components, I guess for the dynamic updates. Oh yeah, because for the dynamic updates, document components, dynamic simulation, data components. So as an example, we did dynamic simulation components. So I guess what I'm going to do is these are my notes for the so I want to do this. So I guess I'm going to do an example where I implement the same thing, an iterator and an iterator and the point that moves. I'm going to do that in native Grasshopper. Sorry, native, yes. And then the next step will be implementing an auto update. So those components just changing automatically. And then the exercise is that we will take this code, the simulation, and we will implement the dynamic simulation component there. That's what we're going to do. Okay, that's what we're going to do today. So how are we going to do that? Well, I'm going to copy myself this code here so that I have it. I'm gonna copy it so that I have my cheat sheet here and that I know where I'm heading to. If I don't do this, if I don't think through what I'm going to talk about, then I start mumbling and like being like blah, 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 whatever. It just doesn't work. So that's spending 5 minutes doing this is actually very healthy for the video. I appreciate your patience holding on to this. Okay. Beautiful. So I think the video will start with an introduction, and then I will record that later, which I need to remember. So I'm going to write myself here record intro because I always forget, and then it's not nice. Record the intro. So now it's here. Record introduction. There you go. And then I'm going to start. Okay, so what we did in the previous video, there will be a card popping up, is that we created a script where we had some code, but there was this area that was persistent data, and that stayed through the life of So what I want to do now then is I want to switch to a Visual Studio implementation where I already have the initial code for this as well. The initial code for this. But I have the initial code for this, and I only have to explain how to write the solver and how to write the persistent data. So then what we're going to do is here, well, I'm not installing Visual Studio right now. So vector components utility, I'm going to create a new folder called development. Okay, so I'm going to create a new folder called development, and I'm going to add here a new item, which is going to be an empty Grasshopper counter, for example. Okay, and then the counter is going to be tree info component is going to be counter, then it's going to be counter, is going to be count number of iterations, and then pcamp, and then this is going to be development. All right, and then the inputs are going to be, okay, this is not the call that I was expecting. This is just spam. And then the inputs are going to be, I'm going to add a value parameter. So I'm going to add a add number parameter. This is going to be value. This is going to be v. Do I need? Nah, I'm going to just use a ticker because I really don't want a ticker. T, and actually I can do this generic because I don't really care what this is because I'm not going to use it. Generic input to tick the component. All right. And then here I'm going to add pmanager.add number integer, which is going to be iterations. And that's going to be it. Iterations, number of times this component has updated. And the item access is going to be item. And this should be an item. All right. Okay. And then object objs is no. How are we handling this? I'm just preparing. Okay. Define placeholder variables. I want to be really, okay, so define placeholder variables. I'm preparing the exercise for the video, okay? And then if we don't get the data, then, hey, Arasto, Thieves, how are you doing? Get data, I'm going to reference it here in an object, return, and then solver, and then the output. My fingers are like not very fluent today. All right. Will I cover it? Event handling? I'm not sure I will cover it in this series, but we could make a video that could go into the general learning C# playlist. That would be nice. Yeah. Okay, so I'm going to do that, and I'm going to and this needs a semicolon here. Okay. All right, continuous execution. All right. Okay, so I think we're ready for recording. So again, I want to start talking about what we did previously, and I want to show how that translates to Visual Studio. So I'm going to show the code, translate to Visual Studio, and discuss adding permanent data. And oh, and I need a reset button. And then pmanager.add generic add boolean parameter reset counter, and then parameter access is going to be item and just a number count. Okay. All right, let's do this. Woohoo! I may have had a little bit too much coffee again. I don't even know how you folks deal with me in this state. I can barely deal with myself. All right, let's do this. Hmm. Let's get started. So if you remember in our previous video where we implemented permanent state using C# script components, which by the way you can check, there should be a card popping up somewhere here, or there should be a link in the description of this video. If you remember from the previous video, we discussed that if we want data to be persistent across different iterations or across different updates of the component, one trick that we need to do is that instead of declaring data or storing data in the main body of the function that takes care of executing whatever the component is doing, what we need to do is we need to add that information, the variables that are going to contain that persistent data, we need to declare them and maintain them outside of that function. Because if you remember, because of the rules of scoping variables in computer programming, whatever you declare inside of a function expires as data whenever that function finishes executing. And if you want to learn more or refresh what scoping in functions means, we also have a video about variable scoping that will pop up in a card, and there will be a link in the description of this video as well. So what we need to do is, because this at the end of the day is a class, is an object that gets instanced and that has a particular function that gets executed when the component needs to update. If we declare variables outside of that function, what we are indeed doing is declaring fields, declaring variables that belong to the class. And whenever that class gets instantiated as different objects, aka in this case different components, each one of those components will have variables that belong to that specific component and that are not shared across components and that are persistent across cycles of execution. That was the logic for C# script components. Well, it turns out that in native, if we do this natively in Visual Studio, it's pretty much the same logic. Because if you remember, if we go back to Visual Studio, what we're doing when we create a component is that we're taking this Grasshopper component class, we are subclassing it, we're creating a child instance, we're inheriting all of that, but we're basically doing the same thing. We have here a bunch of functions that are specific for declaring inputs, declaring outputs, and the one function that we typically use to solve the instance, or where we actually put the code that is going to run every time we execute this component. Well, it turns out that the principle of moving whatever data we want persistent across updates, moving that data outside of this function, that same principle also follows. So the only thing that we need to do is we need to make sure that data is declared somewhere outside of this function. And because this is a class, we can just declare fields for this particular class that will belong to this instance of a component whenever it's dropped on the canvas. So for example, what I can do is I can declare a variable here, and I'm going to call this persistent fields, or I don't know if it's persistent with an E or with an A. I'm going to call this, for example, updates, which is going to be initialized to 0 whenever the component is dropped. So with this, I'm going to keep count of how many times the component has been updated. And then what I'm going to do here is that I'm going to take and retrieve the input. That so I have already pre-declared here two inputs. One is going to be the ticker and one is going to be a reset, just like we had in this exercise here, right? And then, but remember, the ticker is just an input that we use to trigger an update, but we don't really care about its value. It's just for the sake of forcing Grasshopper to update this component. And what we want is to output the number of iterations, the number of updates that this time, I'm going to call these updates, the number of times this component has updated. So the way to do that is every time we solve this instance, we're just going to take the number of iterations, the number of updates, and I'm just going to increase it by 1 unit. And then through the update, through the output, I'm going to say set data in position 0, and I want to output updates. All right, this number here. And with that, we should be good to go. So I'm going to close this. I'm going to close everything, and I'm going to install, I'm going to trigger my Grasshopper plugin, and I'm going to open Grasshopper automatically, and it's loading some stuff, and the file already shows up. Okay, the main file that I'm using for debugging here. So if I now zoom out, I should have here on the PC, I should have a new category that I've created called development. And I have this folder, this component called counter, the one that I just created, right? It has the ticker, it's just generic, and a Boolean, which is the reset, which we will implement very soon. And this is the amount of updates that this component has taken, all right? So here, what I'm going to do is just I'm going to plug a Bologna, a random input, okay? And it looks like it's not working because parameter R didn't collect any data. So let me just plug in a Boolean toggle, all right? And actually, this should be a Boolean button, all right? Which is not going to work right now. But you can see that as I move my ticker, right? Every time I move my ticker, one new input data gets fed to the component that triggers an update, and the number of updates just goes up. All right? So it's the same principle. Now, the only thing that I need to do here is now make sure that I use the reset value as well. So for example, I can do that by saying, well, if let me first fetch that data. So Boolean reset equals false. And then let me, if this, then reference reset, and then if reset is true, then updates should be equal to 0. Okay, I'm going to run this, see if it works. Okay, I'm going to drop the component because I forgot to save this. I'm going to drop the component again. I'm going to drop a reset button, and I'm going to place here a panel. And so I got this, one updates, all these updates, etc. And then I can reset this, okay? Reset, and then updates. You may note that as I reset, I get the number 1, and I'm still pressing the button. And when I let go, I get the number 2. That's because letting go, when it goes back to false, still triggers an update. So maybe if you're annoyed by this is technically true. But if you're annoyed by this, what you can do is you can set this to -2, for example, so that when you let go, the count ends up at 0, if that's what you're interested in. And you can also, if you remember, you can also use a trigger. So what I can do is I can connect the trigger here. I can set an interval, for example, 100 milliseconds, and hit play. And you can see how this trigger is basically ticking my component, and it's updating it every 100 milliseconds, all right? Updating this count. So this is, long story short, the only thing that changes when you want to do persistent data across updates, and you're doing this natively in Visual Studio, is that you need to remember that the fields, the persistence field, are basically fields that you add to the class that is representing that component. So you just add it as a field here. Nothing really different about this. Now, one thing that it's cool that you can do if you do native development is that if you want for some reason to make these updates automatic, right? Like for example, in the previous exercise where we were doing simulations, physics simulations, and you're kind of bothered by the fact that you have to force this one component, the ticker, the trigger, to update externally, there's an option that you can use, which is you can actually write code to have the component update itself. So the component be the one who is triggering, or it's ticking himself at regular intervals, which is something that is actually quite cool. And it's something that we're going to see in the next video. In the meantime, thank you very much. And if you liked what you saw in this video, maybe hit the like button, subscribe to the channel, etc., etc. Otherwise, see you in the next video where I will explain how to implement auto updates in native Grasshopper components. Bye bye. Okay, and now I need to record the introduction. So let's do that. And the introduction is going to be what? It's going to be this, basically. All right, let's do this. Hello, this is Jose Luis here at Parametric Camp, and welcome to a new video in this series, Advanced Development in Grasshopper, where what I would like to teach you right now is how to implement in native Grasshopper the idea of having persistent data that it stays starting over again. Hello, this is Jose Luis here at Parametric Camp, and welcome to a new video in this series, Advanced Development in Grasshopper, where I would like to teach you how to implement persistent data in native Grasshopper plugins. And by persistent data, I mean data that that stays there across different updates, multiple updates of a Grasshopper component. And this is useful if you want to do things as, for example, a counter that every time I update the component gives me a new amount, a new number for how many times the component has been updated. Or if I hit play, I can see this number increasing over and over again for every update. It requires a small trick, which is handling where that data is living inside of the Grasshopper plugin. But it's actually a really common technique for things such as simulations, dynamic simulations. So let's talk in and let's get hands-on, and let me teach you how to do this. Alrighty. Okay, I need to take a break. I have a bio break. Just give me a couple minutes and I will be right back. Hold on. Testing, sound. Yes, sound is there. All right. Okay. Alrighty. So, what are we doing next? Auto updates, which I have absolutely forgotten how to do. So I need to take a look at that right now. So how about we practice this? We make an example here. And I forgot to save. No. All right. So this is what we have right now. And I did have an example of this somewhere. Where do I have an example of that? Where do I have an example of that? I think I wrote some auto updating in Machina. I think. Let me look that up. Where's Machina? Machina, where are you? Machina.net. That's not the one we want. Machina Grasshopper. Yes. I think the WebSocket components had the bridge. Listen, they had an auto update. Update upstream. Auto update the interval. Yes, so yeah, but this had this whole thing that I wrote, which was trying to not expire the solution outside of. I don't think this is what we want, because this had like other stuff. Because I wanted to turn on and off auto updates based on a rule. So I wonder if it's just this what we need. Let me try that. So let's say we implement here P. So I'm going to try things out and see if it works. So, okay, so what am I doing? So there's this thing. There's from the document, that the component you're in, you can get an instance of the document and you can schedule a solution to happen at whatever interval. And with a callback function that you can declare as a delta function, which says that you just do not expire the solution. What I did in Machina was a bit more complicated just because I wanted the auto update to be turned on and off based on whether if there was data coming in from the WebSocket server. So it required like a bit, but here it's just whether if it's on or off. So what I want to do here is I'm going to add a Boolean auto update, and here auto update, and then Grasshopper item, and then p manager add integer update interval in auto update interval in milliseconds. All right, that's also going to be an item. Okay, and then here, what am we going to retrieve? We're going to retrieve a Boolean, which is going to be auto update, and that's going to be false. And what else? Interval is going to be equal to 0. Actually, let me do 1,000 in case there's like a problem with missing data. Can you see my code? So I'm doing do 3, and this is auto update, and this is interval. And then we set the output. And then after this, launch scheduled new update. And then here we say if auto update, then make sure that you take this onPing document, which is returning, what is it returning? It's returning an instance of the object, which we say I'm going to schedule a new solution at this interval. I'm going to rename this to millis. And then the document is going to be given wait, so what is this taken? I want to know what is this taken so that I can explain. And the callback is a Grasshopper document schedule delegate. So I should probably explain what the concept of a callback is. So the idea is that we would do document and then this dot expire solution, and whether if in front of the solution has expired. The current object, it doesn't need to recompute the whole thing. Now, can I create that callback? Can I extract that callback somehow so that I can private over private void? Let's see, private void, if I do a function that returns nothing, and I call this schedule callback, and this is going to take an instance of the Grasshopper document. So Grasshopper document doc, and then it says this dot expire solution false. I wonder if I can just do this and just write here the schedule callback, which kind of works. But let's see if this works. So first of all, does this work? That's the first one we want. Does this work? Okay. So development here. And then a button, a Boolean button. And then we got this for, and then for auto update, a Boolean toggle, no auto update, and no millis. So no millis here. Okay, so then, boop, boop, boop. Okay, so that's fine. And then if I turn this on, auto update, it's working. And then if I crank this down, then it updates much faster. So that works. So I'm going to save this. I'm going to close this. And what if I now replace this with schedule a callback? And I run this and I see if the same thing works. And it is working. I reset. I stop the auto update. It starts. So it works well. Nice. I like when things work well. It's nice. It's very nice. So if that's the case, then the only thing we need to do is explain what I just did in the video. And I think we're actually pretty good on time, so we may be able to Aras too. I did not. I honestly, I didn't even look into it. I didn't even look into it. No. Nope. Nope, 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 nope. to say. I just didn't. I didn't have the time to look into it really. So what we want is this then. So I'm going to remove this. I'm going to keep the inputs. I'm going to keep the inputs here. And am I going to do an introduction? What am I going to do? Am I going to do an introduction? Yeah, how am I going to do the video? Am I going to do an introduction? I think an introduction is nice. So in the introduction, I can say, well, in the previous video, we saw how to update a variable, but it requires the ticker. So in this video, what I would like to show you is how to do it without you know what? We could actually do, how about we just copy and we paste and we get a second component so that we can compare them. Counter auto update. Yes. Yeah. With auto update. And then here we have this. And here I'm going to remove all the additional code I added. This stuff here, and this stuff. So now we have the two separate files. I like that better. Yes. And then in the intro, I show the two files side by side, the two components side by side. And then after the intro, I land here and I say, okay, well, let me show you what we had before. And then what I created a new auto update, and then I created a couple inputs, and then I get into the meat of, okay, so let's do that. Yeah, so remember the introduction, I need to explain what we had before and show a component next to it. Yes, and which actually may trigger the problem that Arastu is pointing out, that when you do auto updates, basically everything in the document auto updates, which is not nice. So, okay. All right, so let's do this. Oh, actually, let me. Oh, there's an ID conflict. Oh, ooh. I need a new ID here. This is what happens with copy pasting. UI, yeah, narrator. Okay. So this one, I'm just gonna copy it here. Okay, and that will give me. That will avoid the error. Okay. All right, we got the counter. Okay. Okay. If you remember from the previous video, what we did was we have a counter component that every time I update externally with some new input, the number of updates, the count of updates goes by 1. And I also could connect a trigger to have this automatically happen at regular intervals. So what I would like to do now is, instead of connecting this artificial trigger, if I want this kind of automatic updates, what I would like to do that is for the component itself to be able to handle that. All right. So what I'm going to do is I'm going to create a new component, which is going to be also a counter, but which is going to incorporate this auto updating functionality in itself. So how am I going to do that? Well, I'm going to close Rhino and Grasshopper. And if you remember, we had this code from the previous video where we had basically the two inputs, the output, and then every time we computed the solver, we just took this global variable in the class, which was persistent, and we updated it by 1 unit. Okay, but we depend on someone externally updating this component for this increment to happen. So what I've done is I've basically copy pasted the same component. I have renamed it to counter with auto update. All right. I have updated here the descriptions, the name, whatever. I made sure to change the global unique identifier because since I copy pasted the file, the identifier is the same and that gives me Grasshopper conflicts. So you make sure that you update that to a new one. And then what I did was I added these two new inputs, auto update as a Boolean, so whether if I want to have an auto update or not, and the interval in milliseconds between updates. So 100 milliseconds, 200 milliseconds, etc., etc. And then the rest is the same. I here, though, I disclosing the solution here, sorry. Here, what I did was I added two variables. I fetched them from the inputs, but I haven't added any code yet. All right. So what this is going to look like is that if we wanted the component to handle auto updating itself, that is something that we need to handle in the function that takes care of updating the component. So what we do in this function is we generate placeholder variables, we fetch the inputs, we do everything that we need to do to update the count of iterations, and we spit that out through the output. But then after that, what I would like to do is, if the auto update flag is on, if the input requires that I keep auto updating, I would like to launch or to schedule or to make sure that I tell the Grasshopper document like, hey, you know what? I need to be re-updated in this many milliseconds. So the way to do that is actually quite simple. So here I'm going to write schedule a new update if necessary. And we're going to start with an if statement, which is if auto update the input, if this was true, then what I would like to do is I would like to schedule a new update in this many milliseconds. The way to do that is first retrieving a copy of the document, the global Grasshopper document that owns the component that I'm in. I can do that by saying, for example, this onPing document. I could also probably retrieve the document object, but this is how I've seen it on the internet done more often. And then here I can access this function that is called schedule a solution. And you can see that in the description you can say schedule a new solution after a specified time interval, etc., etc. The schedule is erased and a solution is executed, etc., etc. Right? So what I can do here is I can pass here now the amount of milliseconds that I want to schedule this new solution for. All right, which is also part of the input. And actually, I just realized I've never used this without the callback. I kind of wanna see what happens. So here I'm going to do with auto update. here, a toggle, a Boolean toggle, and an interval. Oh, and this is updating too. Because of this. True. Yeah, it doesn't happen. Yeah. Okay. Then I'm going to delete this. Am I going to delete this? Yes. Now, something that is important that I add here is also the fact that I can schedule a new solution in whatever milliseconds. But it turns out that if I do that just out of the box, because in the next solution, Grasshopper doesn't see anything that has changed, then Grasshopper will not flag this particular component to be triggered again. Because since the inputs are the same, it sees no difference, and then it just continues without updating the component again. So what we need to do is we need to make sure that that the solution is what is referred to as flagged as expired, which means that we basically force the Grasshopper document to believe that the solution that is currently on is not valid anymore and that things need to be recomputed. And that's why we need to add a call to make that happen. The way that works is that you can see that if I add another comma, I get the second overload of this function, which takes the delay, but it takes this thing called the Grasshopper document Grasshopper schedule delegate as a callback. I don't know if you're familiar with this, but callbacks in computer programming are functions that are designed to be executed at a later time in the life of the program, kind of like multi-threading, kind of like starting a parallel process, so that whenever whatever you're executing ends up executing, like for example, scheduling the solution, whenever that ends, there is a function there ready to be executed whenever that happens. So what I can do here is I can add here a function that I would like to be executed whenever the new solution is scheduled, right? So whenever these 500 milliseconds happen, the new solution is scheduled, and at that point, I would like to execute something before the solution is done. The way that works is that I can write here, because it's a callback, what I can do here is I can write a function that I want to execute. There's two ways to go about this. So what I can do is I can write a function somewhere else. So I can declare a function, for example, private void, and I'm going to call this a schedule callback, something like that. And I'm going to look at the signature of this, and I know I'm going to look at the signature. Can I see the signature? I guess I can't see the signature. I wonder if this is something that we can look up. So let me actually look that up. So I'm going to go to the Grasshopper documentation, which I have somewhere, the Grasshopper SDK here, and I'm going to schedule callback, Grasshopper document schedule solution. Exactly. Where is this? No, schedule delegate, sorry. And so schedule delegate, up, nothing found. So what if I write delegate? Let me find Grasshopper document. Let me look at the class. Let me look at the class and let's see if there's a delegate somewhere on schedule delegate. And what is this schedule delegate here? Oh, it's in the kernel. All right, so this is what it is. So you can see that The Grasshopper schedule delegate, it's a delegate function, which means it's a function that can be passed as an argument to other functions. And we can see that here, and we can see that the signature of this function is that it has to return nothing, and that it has to take in a Grasshopper document that can be operated on. So what this means is that when I write this in my schedule callback needs to have the same signature as the delegate that we're targeting. What that means is that it needs to return void, but also the input needs to be Grasshopper document, and for example, call this doc. All right. And I'm going to close, I'm going to minimize this, I'm going to make this a little bigger. All right. And then what I can do here is I can say that the solution needs to be expired. What I want is to expire the solution. All right. Beautiful. So I'm not really using the document at all here, but I need to have it there so that the signature is the same. And now what I can do is I can just copy this here. All right. And then effectively, this function becomes data that gets passed to this other one. And it's a function that will be executed whenever this solution, after whatever milliseconds, is scheduled. So let me see if that actually works. So let's see if that works. I'm going to open Rhino and Grasshopper. And I have here, I'm going to go here, and I have this new one called counter auto update. So I'm going to copy and paste these folks here. I'm going to add a button, an input button. I'm going to create a Boolean toggle. So if I want to auto update yes or no, and how many milliseconds I want between updates, and I'm going to copy and paste this. So this component is working just as we had before. And if I copy the trigger, you can see that the trigger will also trigger this component just as we did before. All right. Now, but if I turn on the auto update, you can see that now every 1 second, the component is ticking itself and it's refreshing. And if I crank down the time, you can see that that update happens much faster. This is because the component is basically trapped in this loop where if the auto update is on, it schedules a solution, then it expires the solution, so it runs this code again, and because it runs this code again, it schedules a new solution, it expires the solution, it runs the code again, etc., etc. So it's kind of like, if you will, trapped in an infinite loop where each iteration happens at every millis, whatever that is. All right. And actually, it would be wise here to write like some kind of sanity check where you say if milliseconds is less than 5 milliseconds, then you stick to 5 milliseconds, because otherwise Grasshopper may actually explode. All right. All right, beautiful. So we have this, it's working, it's auto updating. The only thing that I would like to wrap this video with is that I'm going to save this. I'm going to close Rhino, and I'm going to show you like a very common way of writing callbacks. Callbacks can be declared as an independent function, and then they can be passed as an argument like this. But it's actually very common to write callbacks as anonymous functions. Sometimes this is called delta functions, basically functions that are written inline that are not declared explicitly outside of there. So a very common way of doing this is, instead of having this declared explicitly, another way of writing this is saying, I'm going to schedule a solution at this many millis, but then the function that is going to be executed after that, I write it here directly using the lambda notation. What that means is that I can say that the function that I want you to execute is going to take something that I call the document, all right? And I'm going to use the arrow notation to signify that this is a function and that I need to execute whatever code is inside of brackets. And then there I can just copy paste the exact same thing and expire the solution. This is identical as writing the function outside and then just passing the name of the function. It's just that we're doing it inline. Some people prefer this kind of notation, sometimes people don't. This is good if you're only going to use it once. If you're going to be reusing this delegate in many other parts of your code, then it's probably good to just have it in one place. All right. And then this just executes, all right? And I think it should be working just like it was working before. So you can see that now this is auto updating, this is going up, etc., etc., and now it's auto updating very fast. And there you go. And I can reset and I can accelerate that by multiple updates, etc. All right. Beautiful. So I think with this is what I wanted to cover in this video, auto updates. And actually what I would like to do also now is make a more comprehensive example of this idea of auto updating for Grasshopper components that deal with simulations, like physics simulations, dynamic simulations, form finding simulations. So I believe in the next video, what I'm going to do is just a hands-on exercise, a practice, where we're going to take this idea and we're going to apply it to a dynamic simulation of particles moving and colliding and etc., etc. Okay, so thank you very much. I'll see you on the next video, and if you liked what you saw so far and if you find it helpful, then maybe give us a thumbs up, like the video, subscribe to the channel, leave a comment, join Discord, ping me on WhatsApp, Twitter, Instagram, whatever you feel. Okay, thank you very much and see you on the next video. Bye bye. Okay, and now the introduction. Okay. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in this series, Advanced Development in Grasshopper, where we're going to continue what we did in this previous video, where we implemented a counter that could count how many times the component had been updated, and it could do it by being triggered by a ticker, or it could do it by having a trigger ping the component over and over again at regular intervals. So what I would like to teach you in this exercise, in this video, is how to implement this idea, the idea that the component may update automatically at regular intervals, but instead of using an external trigger, how to do it internally from within the component. So I would like to teach you how to implement an auto update so that if I turn this on, the component is going to update every 50 milliseconds, every 500 milliseconds, every 1000 milliseconds, or whatever you set it to. And as soon as you turn this off, the component stops updating. It's actually very simple to do, and you're going to find this very useful, especially if you're creating components that do dynamic simulation, relaxation, video games, even in Grasshopper, whatever you do. Okay, so let's take a look at how that would work. All right. Well, the chat got crazy. What's happening here? Roll camera. What do you mean with event handling? Create your own events or using? I agree. In other case, Arasti would be nice to cover both. I mean, learning about native Grasshopper events by creating new ones. Yeah, I kind of hate events so far. Use them a good bit in Unity, and they're super useful, but I find them awkward. I agree with you. I think the declaration in C# of events is a little awkward. I find it much cleaner in JavaScript, for example. But you already know me, folks, that I like JavaScript a lot. So what can I say about that? I guess I'm biased. Maybe with an explanation of it. Yeah, I don't know if I can make that any easier. VR, Unity. I started making an AIM trainer like Kovacs. What is Kovacs? I learned so much with you folks. Kovacs. Oh, videos. What is this? AIM trainer. Ooh, wait. Is this something that I can play with? Is this in here? Is this in here? Can I play with this? Well, you know which game is awesome for VR and for this kind of training? Super hot. If you have ever play this game. It's extremely fun. It's beautifully, it's like visually super exciting. Give it a try, okay? I highly recommend it. So you were doing Kovacs, however it's whole because most of people that the tedious and boring. I continue when I have more motivation. Not so interested in VR for now, so I don't know much about it. Yeah, UIs are kind of boring, I have to say though. If I something that I didn't find that was handy for this time, so I get a delta multiplier correctly, independent from FPS. Exactly, Nicholas. Using time deltas is very important when you do animations in VR or Unity. Oh, we should do Unity at some point here, right? Mm-hmm. So this is how do we pass extra arguments when using a callback? You can't pass extra arguments because callbacks. So callbacks are designed to expect what they expect, and that's why you have this signature. So this function cannot take a callback that has a different signature than what it has to have, which in this case is the Grasshopper document and returning nothing. It just and if you want to pass more data, you can't, because the one who's actually passing the data, the arguments, is the function, the schedule solution. So you're very limited in what you can do actually. If the signature of the callbacks is given to you, if you're the one designing them, then you can design whichever signature. You will have to define your custom function exactly as to. All right. So, okay, so let's do a simulation exercise now. Okay, so let's take what we had. I'm going to save this here. So this is good. I'm going to save this here. Now I would like to, we're not doing Machina for Grasshopper. No, we're not doing that. And let me write here myself a couple reminders. And part 2 C# example, another card to scoping. Auto updates, I didn't have to say that there was a card anywhere. And then auto updates and simulation. So we're going to take the example that we did. Oopsies. We're going to take the example that we did here and previous components. Which one are we going to do? The cool one, right? Crash, crash, crash. Boo. Yes, I want to stop debugging. Okay. So crash. And here, preview components. And what do I have here? Oh. Oh, no, I need to move this a little farther down. I'm very hungry. Am I the only one who's hungry today? Oh, why is this taking so long? See you, Pedro. Bye. Oh, my hair is crazy today. Why is this? Oh boy, what have I done? Have I killed Rhino? Let's try again. Okay, and let's open Grasshopper. Okay. Let's open Grasshopper. And I've got a preview here. We open the file. And I want to take a look at the simulations we did and see which one we implement. Those were here. Dynamic simulation. What was this? Oh, this was the bounding This was the bouncing. This was the rope. And what was this? Anchor. I don't remember what we did. This is 2 points, 2 points, 2 points. Okay, so let's just add 2 points and link them. So set 1 point, set 1 point, and then oh, I don't know, rectangle. Okay, yes. Okay, so we had this one. All right, and I'm going to. Okay, so that it was okay, but I want something a bit more exciting for the video. So this one and this one. I'm going to hide the mesh exercise. I'm going to hide this. So what did we have here? This was the pendulum. With the arrows here. And I'm going to stop here. And I think this was the one with the chain, right? I think this is probably the one that I want to replicate. And let's run this. There you go. Yeah, this is the cool one. And we want auto updates here. Okay, so I guess what this means is, okay. So I can probably start from the inputs already in place. Here. Okay, so in the video, I'm going to have an introduction where I'm going to show. Actually, let me save this in its folder, native components. What was this? Okay. So I'm going to create auto updates, simulation components, simulation components, auto update components. And so what I would do is, well, first I'm going to save this as here. I'm going to call this E11 auto update components. I know, but I'm not doing it here. You're right. No. This is not the file. Yeah, I don't need this. Sorry. Okay. Oh boy. Fine. Okay. Okay. Fine. So here. Sorry, I'm a little messy right now. So I do this in the other file because that's the one. I do it in the Grasshopper in the native project. Okay, so I'm going to start. The introduction video, I will show how to create a simulation and do the auto update. And then what I want to do is I want to start the video by saying, okay, if you remember, we did a bunch of simulation components, the one that did the bouncing, the one that did the pendulum, but we also did this one that was a sagging chain, all right? So, but this one relied on the trigger, blah, blah, blah. So what I would like to do is implement the exact same thing, but with the auto update. So what I'm going to do is, first of all, and then I will switch, I will have the file ready with all the inputs, and I will get on to the code. And I may actually want to have a side-by-side Visual Studio versus the code in the component, and then so that I can just copy and paste, basically. Okay. All right, so let's do that. So this is going to be the intro to the video. The not the intro, the after the intro. If you remember from the exercises that we did when we were looking at C# scripting within Grasshopper, you remember that we did 3 examples for dynamic simulation. One that was this point that is bouncing off the borders of a rectangle, or this pendulum that is kind of bouncing with an elastic or a springy rope connected to it. And the third one, which was modeling the sagging of an elastic chain that looks something like this. So I can turn it on, I can update. Sorry, I have 2 nodes that are connecting the line. I have a bunch of options such as how many subdivisions I want in between them, how many subdivisions, the mass of the elements, where the gravity is pointing, the stiffness, etc., etc. And then I could turn on this trigger to have the simulation update over time. And I could even interact with the simulation and move the objects and things would automatically update. And I had these arrows, these vectors pointing at where the velocity of each one of the nodes is at any given point, correct? So what I would like to do is I would like to show you how to port this example, but instead of, which looks something like this, is basically if you reset, just turn everything back to standard, and otherwise just do like a very simple physics simulation, calculate gravity, the spring forces, and add them all together, and keeping the global state of what's going on in the simulation as a list of nodes, those are the particles, and a list of velocities, which is how those particles are changing every iteration, every frame. So this is going to be useful for us to relearn what we saw in the previous videos, which is how to do persistent data in native Grasshopper development. But at the same time, I would also like to improve this example by not relying on the trigger anymore, but implementing the possibility of having automatic updates and be the one and be the component and have the component be the one who controls how it updates itself. Okay? So what I'm going to do is I'm going to prepare the component offline and let me show you what that looks like. All right, so I think I can close this. I can close this because I do have the code somewhere here. Yes, and I am going to open my Visual Studio project. I'm going to leave this here, actually. Why not? I'm going to leave that there. Okay, and then, oh, I closed the Explorer. How do I bring up the Explorer again? Oh, I always forget that. Solution Explorer here. Okay, so, and view properties. Where are the properties? Properties window. No, here. Properties window. There you go. Okay, how are we doing, folks? I think this one is going to be fairly quick because we're not going to really And I'm going to add a new folder. It's going to be called simulation. And in simulation, I'm going to create a new item, which is going to be, what are we calling this? Elastic chain, for example. And I'm going to drop this here, elastic chain. Simulates the formation of an elastic chain over time. And then category is going to be pcamp, and subcategory is going to be simulation. Okay, beautiful. Now I'm going to open a code editor here, and I'm going to copy this thing that I had on the side. I'm going to put that on the side as well. All right, and I'm going to have the two things together. And therefore here in the inputs, yeah, I'm not going to do this on the video because it's going to be boring. So I'm going to say add a Boolean parameter, which is going to be called, I'm going to add a Boolean that's going to be the reset. Now, well, I'm going to reset simulation and then item. And in properties, why is this not here? Why is this not doc? Okay. Okay, parameter access. And then here I'm going to say pmanager add boolean, and then auto update, and then auto update, automatic updates. This is what's tedious about native Grasshopper development. It's sometimes for complicated stuff, it just takes a long time. So I'm going to add interval. So that's going to be auto update interval in millis, and that's going to be an item. All right, I'm kind of bored doing this, so if you want to give me some gossip or tell me some stories or say hi in the chat, I will be more than welcome to be entertained while I'm putting this together. P manager, so add point, that's going to be anchor 0. I'm going to call this A0. First anchor point, item, and then I'm going to call same thing and A1, second anchor point, then pmanager dot add integer. So that's going to be what? Node count. This is going to be C. Number of chain subdivisions. And then it's going to be item. Then the mass. pmanager, so add number, and that's going to be the mass. Particle mass, and then item. pmanager dot add vector, and then gravity direction, gravity force, and then item. And then what else do we have? Stiffness. Oh, pmanager dot add number, and then stiffness as stiffness spring stiffness factor, and that's going to be an item. What else? Friction. I'm going to call this friction factor. It's also a All right. Okay, so that's one thing. And what was PC and new polyline? Okay. So P were the nodes, V the velocities, and P the polyline, and C the polyline. All right, so that's the outputs. P manager.add. What do we have as outputs again? P is the point. Add point parameter, and that's going to be, those are going to be the nodes. Chain nodes. Chain nodes. And this is of the type list in this case. Okay. Now here we have to say to P manager, we need to add a vector parameter, velocities, that's going to be V, and then velocity vectors, and then this is going to be a list element. All right, and then P manager dot add, what are we adding here? The polyline. Add polyline. We don't have polyline, we just have curve, right? So, and that's going to be the chain. Chain polyline. And this is going to be an item, I believe. Correct? Yes. Hey, Divankit. Nice to meet you. Thanks for jumping in. I'm very happy. I'm very happy the list is helping you. Keep pushing it. There's a lot to learn and a lot of cool things to do. And then here we need to pick up all this stuff. Oh boy, that's gonna take forever. So I'm going to minimize this. I'm going to start here. Okay, Boolean reset. Oh, I need to be strategic about names. I would like to have the exact same names here, so that I can literally copy paste the code. So bool reset bool auto update. Auto update is false. Bool millis equals 1000, for example. Point 3D anchor 0 is equal to point unset. Damn it. Point 3D, sorry. Hey, Divankit, how did you learn about us? How did you end up here? How did you first hear about parametric camp? If you don't mind me asking. Oh no, this is not, this is an integer. So, and then node count, and then it's going to be equal to 10, for example. Double mass is going to be equal to 0. Vector 3D gravity equals vector 3D unset. Unset stiffness equals 0, and friction. Frication? What the hell is that? Again, frication? Why? Oh boy, I think I need a break. And then what else do we have? Oh, and now we need to fetch them. I think that's it. We need to fetch them. So that's going to be, what is it that going to be? All right. If da.get data from 0 and reference reset, return. Okay, so I have 3, 6, 9, and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, I believe. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and then it's reset, auto update. This is millis. This is anchor 0, anchor 1, node count. This is nodes, node count. Here we got mass, here we got gravity, here we got stiffness, here we got friction. Okay, and here we got placeholder variables, retrieve inputs, solver, and then outputs. Okay. Okay. Beautiful. So what I've done here to save you, the viewer, the hassle of like sitting and watching me do this manually, which is a bit tedious. And what I did was I just opened a text editor, in my case, Visual Studio Code, which is different than Visual Studio, which is what I have on the left. I know this is also confusing, sorry. You can use any code editor that you want. And I basically copy pasted the code in the C# component that we prototyped in the previous video. If you want to remember how we did that, there's a card that is going to be popping up here on the corner, and also there will be a link to the original video where we developed this exercise, also in the description of this video. Okay, so I copy pasted the code, and then I created myself a new category called simulation and a new component called elastic chain using the Grasshopper template that we have seen in previous videos in this series. I added here a bunch of names. I make sure that the category is simulation. And then for the inputs, I registered the exact same inputs that we had in the original C# script component with two exceptions. I added an auto update as a Boolean, and I added an interval in integers, which is how many milliseconds I would like to have between updates of the component. All right, but the rest is the same. We have a Boolean for whether we want to reset the simulation. We have 2 points for the 2 anchors, how many nodes we have for the chain, the mass, the gravity, the stiffness, and the friction as numbers and as vectors. And then what I've done as well is I have added the output, which is it's the list of nodes as points. And remember, this is a list because I just want many of them, the velocities as vectors, and the chain as a polyline. Grasshopper, native Grasshopper doesn't have an explicit polyline output or type. We just use the generic curve, which can also accept the subcase, which is polylines, which is like discretized points, right? Discretized curves. And then in the instance solver, I have already added the placeholder variables and the retrieval of those values from the inputs, something that we're also familiar with from previous videos. The only thing that I've done is that I have carefully designed the names of these placeholder variables to have the exact same name that I used before in the C# prototype that we wrote in the previous video. I did that because what I want is, since the code is going to be the same, I just don't want to have to like copy again and write the same algorithm. What I would like to do is just copy paste the exact same thing. So that's why I use that's why I use the exact same names, sorry. And just to make sure that this works, I'm going to run this. It's not solving anything, it's not outputting anything, but it doesn't matter because it should already show up as a component that I can drop on my file. So if I go to Parametric Camp under simulations, I should already have elastic chain that takes up a bunch of stuff. So let me actually draw full names. All right. And then I can fill this in with I can plug in a bunch of sliders here, which I'm going to do offline as well. Beautiful. So the next thing that we have to do is just going to be super simple. Well, first of all, what I'm going to do is I'm going to take the exact same code that I prototyped and I'm going to copy it and paste it in the solver, except for the part where I did the outputs, because the outputs, remember, in native Grasshopper are treated slightly different. So I'm going to take the whole code and I'm going to paste it here. All right. And then you can see that something is not working right now. I don't have a variable called nodes or velocities or nodes or velocities. I'm getting that error, all right? And if you remember, that is because the nodes and the velocities is data that is permanent across different updates of the component because they need to change over time. So we've talked about this before, and you can see how in the C# implementation, they were declared outside of the main solver function. They were declared here as a separate entity. So what I can do is I can take and copy this and declare them in the parent scope also as well here. So I can just go all the way at the beginning and I can say declare persistent variables. All right. And I initialize them to empty lists. And then here, now the whole code should actually work. So now if I run this code, I'm going to save this. I'm going to run this code. All right. And things should actually work. I don't have any errors. Is that true? I don't have any errors. Let me take a second to plug in all the data in here. I was interested in learning. Oh boy. Oh boy. I'm going to have to do this manually. Right, I'm 7. I was interested in learning more about parametric and chemistry and learning parametric camp. All right, well, good for you too. It made you land in the right place. The band kit. All right, I appreciate your thanks. Thank you. I'm very happy this works out for you. Components, no recovery file. I don't need this. I also want to open. I just don't want to do this manually. I just want to copy paste. Please, please, please let me copy paste. I'm going to copy and paste this here. So I have the reset button. I have a toggle. No, toggle gate. No. Boolean gate. Boolean toggle. Yes. The milliseconds. Here. 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 I'm going to have 2 points. Can I turn this off? Where is this? Can I turn that off? Yes. Can I drop a couple points here? Set 1 point. Set 1 point. I'm going to save this as components here. Okay, and then node count, mass, gravity, stiffness. And actually, gravity should probably have a slider. And there you go. And index was out of range, must be now negative. Parameter name index. I don't know what happened with that. Oh yeah, I need to reset. And let me velocities here. Right, and I'm going to also have here the outputs. DA set data. That's going to be nodes. Set data list. DA set data list 1 velocities. mda dot set data to, it's a new polyline with nodes. Okay. And then a trigger here. And there you go. Very nice. Okay. Very nice. I like it. Okay. Okay, I have added all the proper inputs, all the sliders, the Boolean values. I have added the outputs and the visualization of the vectors. And I also added, which I forgot, I've added the outputs to the set. So I made sure that the nodes were output as a data list, the velocities as a data list, and a new polyline that was created on the fly with the nodes as part of the third input. So what you can see now is that I have my simulation that I can reset, all right? And then I can turn the trigger on, the simulation will execute, and I have the exact same behavior. I think I can interact with the simulation, etc. I can see the velocity vectors, same thing as we had before. So it was just as simple as copy pasting with the exact same names. The only thing that we don't have is that if I stop the trigger and I turn on the auto update, it doesn't automatically update because I haven't implemented that yet. So it's going to be super easy as we saw in the previous video. So let's take a look at that. So we're just going to go back here. We're going to save the file and we're going to say, well, we're going to speed out the outputs, but then I'm going to schedule a new solution. And the solution is going to be scheduled the following way. We've seen this in the previous video. What we're going to do is we're going to say if auto update was on, so that input that we got from the second input, all right? If the auto update is on, what I would like to do is I would like to first retrieve the current document and schedule a solution at a particular interval, which is going to be however many milliseconds were given to me as part of the input. All right. And then, if you remember from the previous video as well, now I need to add a callback, a function that needs to be executed whenever that solution is scheduled after 100 milliseconds to 100, whatever that is. So I'm going to write a lambda function, an inline function that's going to be a function that is going to take the current document, because that's part of the how the signature of the delegate is. We saw that on the previous video. Sorry to say that again. And then I'm going to make sure that the solution is expired. All right. All right. And then with this is what we did before, correct? Yes. All right. And then with this, we should be good to go. Let's see if this works. All right, so I have my 2 points here and reset my simulation, and then I'm going to turn auto update on. And I thought it wasn't working. It's just very slow because it's at 1000 seconds. So let me set this to 20 milliseconds. I thought it wasn't working. I was like, what the hell? Let me reset this, and the same thing. But now it's much more elegant because the update, this is unnecessary anymore. The update is happening from within the component, okay? Which is kind of great, all right? Beautiful. So in the C# script prototypes, we have the 2 other dynamic simulations, but I'm not going to do those here. I'm just going to do those at the very end of this series as an exercise, but I hope this was useful for you to understand how to create components to do dynamic simulation and have them update themselves. All right? Beautiful. Then with that, I think I'm good for this video, and let's move on to learning more things in this series about how can we do advanced development and cool things developing native plugins for Grasshopper. Thank you very much. If you like this, maybe subscribe or like the video or say hi, and otherwise, see you on the next videos. Bye bye. Okay. All right. Am I the only one who's tired here today? Whew, that was a lot. I mean, I'm complaining, but like you folks sitting through this whole thing as well. I don't know if I would do that for myself. Okay, so this is good. The files are good. I think we're good for today. And we're kind of on time, especially because we started a little later. So it's noon. Okay. Any other questions, comments? So what is next on the list? So we have to do custom previews. So we need to do some of that. How is that handled? And I think it's slightly different than with C# scripting. I forget. So I need to look into that. Then we're going to do version management. That's very cool. So when you make a version of a component and then you deprecate that component so that it doesn't exist anymore, that's a very good thing to learn. Then external libraries, so how to load external stuff. And we're going to replicate some of the examples that we did for C# scripting, I guess. Custom data types, shared data between components. I guess all of that we can do as well. It's on the list. So we're actually very close to finishing. We only have like 4 or 5 videos until we're done. So that's cool. Okay. So with that, I'm going to call it a day, and I'm going to start my Friday, which looks like more work. And editing these videos, I typically edit the videos right away, so that I don't forget what I did. Thank you very much, everyone. It was a pleasure to be here. See you next week, hopefully. We will continue making more of this, unless something changes. And again, if you want to continue the conversation or hang out or whatever, we have a Discord server. The link is in the description of this video. You're welcome to join. It's free and open for everyone. And in the meantime, thank you very much and see you in the next video. Bye bye.